Today's lesson is a continuation of section 4.1a. We are going to review how we generate the values on the unit circle and then how we use the unit circle with the ordered pairs to help us find different trigonometric ratios. So I have here on my first screen the 30, 60, 90 triangle on the unit circle where we would normally have a 30-degree or pi over 6 angle. Because we know on a unit circle the radius is 1, the hypotenuse is 1, the side opposite 30 degrees is 1/2, and the side opposite 60 degrees is square root of 3 over 2. That means that the ordered pair up at the point on the circle right here comes from the horizontal piece right here being square root of 3 over 2, and then the vertical piece, of course, being 1/2. And so that's our first ordered pair. If we move down to our 45, 45, 90 triangle, we're at the middle position. And when our radius or hypotenuse of that special right triangle is 1, our horizontal piece is square root of 2 over 2, and our vertical piece is also square root of 2 over 2, giving us that ordered pair. Finally, we turn our special right triangle so the 60-degree angle is at the base with a hypotenuse of 1. So the side opposite 30 is the horizontal piece, and that's 1/2. And the vertical piece is the side opposite 60, and that is square root of 3 over 2, giving us our ordered pair. So if I move down, you can see the ordered pairs for 30 degrees, 45 degrees, and 60 degrees. Notice when the base angle is 30, 1/2 is the value of y because that's the side opposite the 30-degree angle. This ordered pair flip-flops for 60 degrees. Instead of being square root of 3 over 2, comma 1/2, it's 1/2, comma square root of 3 over 2. And then the 45-degree angle is the easy one to remember because it's square root of 2 over 2. So what I want to do here is I want to generate all the different ordered pairs on our unit circle. I'm going to start with the positive and negative x and y axis positions. Of course, if we're on the unit circle, that means the radius is 1. So that has to mean this ordered pair for the positive x-axis would be 1, 0. The ordered pair for the positive y-axis would be 0, 1. For the negative x-axis, it would be -1, 0. And for the negative y-axis, it would be 0, -1. What makes the quadrants different? Well, it's all about the signs of the ordered pairs. In quadrant 1, we know both x and y of all points graphed are always going to be both positive. But if you graph a point in quadrant 2, the x coordinates are negative while the y are positive. In quadrant 3, they're actually both negative. And in quadrant 4, x is positive while y is negative. So how does that affect what we say for our ordered pairs? Well, there's some symmetry. For the multiple of pi over 6 directly across from the 30 degrees, the only thing that's going to change is the x coordinate is going to be negative. So that's going to be negative square root of 3 over 2, comma 1/2. That's also true for the multiple of pi over 4. That means the ordered pair is negative square root of 2 over 2, positive square root of 2 over 2. And then for the multiple at 60 degrees, that ordered pair becomes negative 1/2, comma square root of 3 over 2. So clearly you see the symmetry, same ordered pairs for the multiples of pi over 6, pi over 4, and pi over 3, but in quadrant 2, the x coordinates are negative. How about in quadrant 3? Well, if you follow the spokes of the angles, the multiple of pi over 6, the only thing that changes is both coordinates are negative. So it becomes negative square root of 3 over 2, comma, negative 1/2. For the multiple of pi over 4, again, both coordinates are negative, so negative square root of 2 over 2, negative square root of 2 over 2. For the multiple of pi over 3, it's going to be negative 1/2, negative square root of 3 over 2. Then we come to quadrant 4. So in quadrant 4, at those multiples, the x-coordinate's positive while the y is negative. So for the multiple of pi over 6, that's the 11 pi over 6, it's going to be square root of 3 over 2, comma, negative 1/2. For the multiple of pi over 4, it's going to be square root of 2 over 2, comma, negative square root of 2 over 2. And for the multiple of pi over 3, it's going to be 1/2, comma, negative square root of 3 over 2. So it's really very easy to generate the whole unit circle if you know the key ordered pairs in quadrant 1. That would be these, as well as, of course, knowing the positive and negative x and y axes. You can generate everything else based on the signs of the values in each quadrant. All right, now let's apply it. You're going to have to flip back and forth between here. But for instance, the sine of 90 degrees. If you know what the value of 90 degrees is, I can go up here, the ordered pair, I'll even write the ordered pair. The ordered pair there, of course, is 0, 1. The sine is which value? Well, we have to know the sine value is the y value, so that means the sine of 90 degrees is 1. How about pi over 4? Well, again, you can look up here at pi over 4 if you want, but the ordered pair is square root of 2 over 2, square root of 2 over 2, and pi over 4 is quadrant 1, and of course cosine is x, so that would be square root of 2 over 2. How about the sine of 5 pi over 4? Now you got to think, where is that? The multiples of pi over 4 are the odd multiples. So in quadrant 1, it's 1. In quadrant 2, it's 3 pi over 4. And in quadrant 3, it's 5 pi over 4. So when we're trying to find the sine of 5 pi over 4, both x and y are negative when we are in quadrant 3. That's the quadrant we would be in. Sine, of course, is y, and this would be negative square root of 2 over 2. Cosine of 135, that is also a multiple of pi over 4, but it's quadrant 2. That means that the x is negative. I think about that quadrant, while the y is positive. We only really care about x, and that would mean our value is negative square root of 2 over 2. How about the tangent of 5 pi over 4? Now, it's the same information as number 3, but tangent, we have to remember, is y over x. So we're actually taking negative square root of 2 over 2 over negative square root of 2 over 2. Well, the x and y values are the same, essentially, so that's going to reduce to 1. How about the tangent of 180 degrees? 180 degrees, the ordered pair is negative 1, 0. And tangent is y over x, so we have 0 over negative 1, which we have to know becomes 0. The sine of negative pi over 4. Now, our rotation is clockwise to quadrant 4. It's a multiple of pi over 4. The x is going to be positive square root of 2 over 2. The y will be negative in quadrant 4. That's the quadrant. So sine is, of course, y. So our answer is negative square root of 2 over 2. How about the cosine of negative 90? Well, you're going clockwise. Negative 90 would be the ordered pair 0, negative 1. Cosine is x, so that means our answer is 0. Let's move down to worksheet B. This is a little trickier. 150 degrees. Now you may have to think, where is that? That's 30 degrees less than 180, so that's really 5 pi over 6. And our ordered pair there, if you want to look, is when it's negative square root of 3 over 2, comma, 1/2. It's all the way up here. It's this ordered pair right here. And so we have to understand that and have to understand a sine is y, so that's 1/2. Now, I know they didn't ask for secant, or cosecant, I'm sorry. Cosecant of 150 degrees, if they asked for it, would be the reciprocal of that value, or 2. It's good to start thinking in those terms. Cosine of 7 pi over 6. Well, 7 pi over 6 is the multiple of pi over 6 in quadrant 3. So that's going to be negative square root of 3 over 2, negative 1/2. We want x. So our answer is negative square root of 3 over 2. If they had said, what's the secant of 7 pi over 6, you would have to take the reciprocal and you would get to rationalize it. And that would really mean negative 2 square root of 3 over 3. Again, I'm trying to show you some extra things here to help you understand. How about the sine of 5 pi over 6? Well, remember, that's the same as 150 degrees. So they're really asking the same question as number 1, and that answer would be 1/2. Cosine of negative 135. That means you're in quadrant 3 going a clockwise rotation. It's a multiple of pi over 4, and both coordinates are going to be negative in quadrant 3. And cosine, of course, is the x. It really didn't matter, but it's good to know what we're finding. So that's negative square root of 2 over 2. Tangent of 9 pi over 6. Well, it's helpful to reduce that to 3 pi over 2. Tangent y over x, and that's a special position, and the ordered pair is 0, negative 1. So that means we have negative 1 over 0, so we need to say undefined. Tangent of 135, that would be quadrant 2. We're thinking y over x, of course. In quadrant 2, that's going to be negative square root of 2 over 2, positive square root of 2 over 2. So when you take y over x, you're really going to have essentially the same thing, but the value is going to be negative 1. Negative pi over 3. We're going clockwise. It's a multiple of pi over 3 in quadrant 4. So that means our ordered pair is going to have to be 1/2, negative square root of 3 over 2. Sine is y, so negative square root of 3 over 2. Last one, cosine of negative 120. So going clockwise, 120 would be in quadrant 3. It would be our multiple of pi over 3. So negative 1/2, negative square root of 3 over 2. Cosine is x, so that means negative 1/2. Again, we could have done the reciprocal of any of these, like the secant of negative 120 degrees would be 2. All right, I hope that helps you understand the unit circle a little better and how you can use it to help you find values. But it really boils down to this circle you see here and learning all those ordered pairs. The faster you learn them, the better off you're going to be. And hopefully you're going to keep in mind all the degrees and radians you learned earlier. Your homework is to finish section 4.2a in My Math Lab. Hope you have a great day. We will see you on Thursday.